Hello, 5th graders, and welcome to our second ebook read-aloud for our science course this year. The ebook in question is this one on screen titled Using Scientific Tools, as found in today's science lesson, Unit 1, Lesson 4, Models and Systems. Now, before we jump into today's ebook, I want to give you a quick reminder. Remember, folks, that when we're about to read an ebook in your science course, it's always a good idea to check what pages it's actually asking you to read. In this case, today's ebook, we're only reading pages 36 to 41. That's only 5 pages today, so we're not reading the entire thing. Now, you're certainly welcome to read the whole thing if you like, if you find it interesting, but please don't feel like you have to, everybody. For today's lesson, just these 5 pages is fine. So be sure to pay close attention to that in the future, okay? That said, now that we know what we're reading, let's go ahead and click on the Open eBook button there and jump on in. There we go, should be able to see our title page today. Now bear in mind, since we are trying to get to page 36, that's where we're starting. I could just click on the arrow to turn the page over and over again until I get to page 36. But there is a little shortcut I could use. I know we may not be able to see it on my camera feed right now, but right underneath the body of the book, there is a little box that says Page. If you type in that box the page number you want, in this case I'm going to type in 36, type it in and then click the little button that says Go. It'll take you straight there. So as the French would say, voila, there we are. So let me go ahead and zoom in a little bit here, and let us get started with page 36, which is Chapter 4, Models as Tools. Scientists often use words to explain their findings, scientists like this guy. But presenting ideas in a visual way, as in with a picture or a model or a chart, is sometimes more effective. Such visual models represent a real object or process. Models may even explain a law of nature. Some models are two-dimensional, or 2D, while others are three-dimensional, or 3D. Other models may move in some way. Whatever type of model, it can serve as a tool for understanding. So some examples of models we got on screen there. First of all, that scientist looks like he's holding a model of a molecule of some type, showing how the different atoms in that molecule are bonded to each other. We also got a model of a plant cell, showing what the inside of a plant cell looks like and all the little organelles you would find inside. Also got a model here of the Earth, showing a cross-section of the inside and the different layers we would find in the Earth from the inside out. We got the inner core, the outer core, the mantle, and the crust. And then of course down here, I trust we've probably all seen at some point a model of our solar system that shows our sun and our 8 planets in order. So any kind of visual model is a nice way to show a scientific concept that maybe is better than just words. Okay, next page, we got models of how things work. Various natural cycles and laws of nature are often hard to grasp. They may be very complex. Models can help make these concepts more understandable. So again, we got another scientist over here holding a 3D model of a molecule of some type, showing all the different atoms bonded together. Over here we have ourselves a 2-dimensional model, or a model drawn or printed on paper. This one is showing the water cycle. So the question being asked here is, what happens to all the water on Earth? This 2-dimensional model helps us visualize the process. The arrows show the constant recycling that occurs. So it's showing how water in the oceans and lakes, when it gets heated up by the sun, will evaporate, turn into water vapor, rise up into the sky, cool down, condense into clouds, and then when it passes back over the land, will fall back to the earth in the form of precipitation, either as rain, snow, sleet, or hail, and then run its way down the mountainsides in the form of rivers and streams, make its way back into the lakes, evaporate again, rise up, condense into clouds, fall back to earth as rain or snow, run their way back to the oceans and lakes, and so on and so on. So, once again, it's a process that could be tricky to just explain with words, but this visual model, or this picture, can help make it a lot more clear how the water cycle works. We can also have ourselves a 3-dimensional model right here. This one's showing a model of an architectural model house. So, when architects or builders or construction workers are building a building, or any kind of structure, they sometimes like to create a little model of it first, so that people can see what the finished product looks like when it's full to scale. So models are very, very handy in this way. Alrighty, last page. This is going to be now computer models. Computers make new types of models possible. Scientists can build computer models that are viewable at different angles and at different layers. Also, models can show natural processes of all kinds in a step-by-step manner. The question at the heart of some computer models is, what if? What would happen if this or that condition changed? How would it affect the model? This type of changeable model is a computer simulation. It's a good word. Scientists of all ages make use of computer simulations. So as a quick example, you can see over here we got ourselves a young man who is displaying a computer model of a car. So you can probably bet that he is a car designer. And he's making a design of the car he's building in the computer first in order to see all the different parts of it, get the measurements right so that when they actually start building the real thing, they can base it on the computer model first. Some of the other questions that computer models can be used to answer are, how does an ecosystem respond to different conditions? So somebody could build a computer model of say a rainforest and make like a bunch of digital animals and digital plants in this ecosystem and then just see how they react to one another. That could be an example of a simulation. You could also do, how does how does a building stand up to earthquakes? So somebody could build a computer model of a building, like you guys probably do when you play Minecraft or Roblox. You build all kinds of structures and buildings in there, and then see how they might withstand forces. So build a building, and then digitally create an earthquake and see if the building can stand up to it. That's something that real architects might do when they're trying to design a building in a place that gets a lot of earthquakes, like even here in California or in Japan, and try to see if the building would be able to stand an earthquake in real life. So these are some examples of computer simulations. And with that, folks, we have now covered the 5 pages that we needed to for our ebook today. So at this point, we could always just go back to the button up here that says Back to Activity. And from there, just go ahead and resume your science lesson today, okay? So hopefully this gave you a nice little insight into the different types of models that scientists like to use, whether they're 2D, 3D, or computer models, and how they can help us understand scientific processes all around the world around us. So take care, folks. Have a great rest of your day. Finish up your science lesson. We'll see you next time.